All right, today we're going to look at, we've been working with polynomials, what we did last week, and did, our long division and synthetic division. We also could figure out, using synthetic division, if a certain binomial would have been not a polynomial, but a factor of a polynomial. So what we're going to look at now is the graphs of polynomials. When we graph lines, like an y equals 3x plus 2, let's say, we get that y equals mx plus b form, that's just a straight line. And then when we did quadratics, like x squared plus 2x plus 4 or something like that, it was a parabola, right? Okay, well now, when we get higher degree polynomials, it's going up and down more than once, all right? Changing direction and stuff. So we're going to talk about end behavior, what's happening at the very end, the far right, positive infinity, is it going up or down? And the far left, negative infinity, is it going up or down? And we're going to figure out mins and maxes, all right? Because it's going to have a couple mins or a couple maxes depending on how many times it changes directions on us. Okay, so we'll use our graphing calculator to do that, as well as there's some things we can look at when we just actually look at the polynomial. Just by writing it out, we can tell what's happening on each end. Okay, so we can figure that out right away, what's happening on each end. And then we'll use our calculator to help us find the mins and maxes of it. All right, so again, what it's called is end behavior at each end, and then turning points are mins and maxes, okay, when it changes directions, okay? So here's the different degrees, up to the 5th degree, but we call it a linear function if it has a degree of 1, x to the first power. Quadratic is x squared, degree of 2, parabola. A cubic function is a degree of 3. So usually what happens is it crosses the x-axis that many times. Degree of 2, this one only looks like it crossed once or hit once, but parabolas a lot of time will hit twice. Degree of 3 usually crosses the x-axis 3 times. Degree of 4 we call a quartic. As you can see, this one crosses the x-axis 4 different spots. And a quintic is when the degree is 5. And if you count, you could see that it crosses the x-axis 5 times. We don't have a special name if the degree is 6 or bigger. We just say 6 degrees, 7th degree, whatever. Okay, but this is from last year's book, this slide. So a lot of this stuff we did last year, just like most everything we've done in here. Okay, so end behavior is a description of what's going on with the function at the very far right, positive infinity, and at the very far left, negative infinity. It says the degree and leading coefficient determine its end behavior. So if I look at the degree and the leading coefficient, I can tell what's happening at each end. I don't even have to look at it on my calculator. But if you want, you could just punch it in your calculator and tell also. Okay, so here's how you tell. Okay, if your leading coefficient is positive, just like the parabolas, if it had a positive a value, it opened up, right? So the far left would go up and the far right would go up. If the leading coefficient, the a value, was negative, it opened down, remember? Okay, well, the same idea. Okay, so I always concentrate on the far right. So if the leading coefficient, that first term, remember, we got to put it in the right order, like we did last week with our division of polynomials. We put the highest exponent and then we went down in order, remember? And if something was missing, we added a 0, right? We don't have to worry about adding the 0 on this stuff today, but we have to get the highest exponent on the far left when you write it out. And that first number in front of that x, usually it's an x, but sometimes it's a different letter, that's a positive number, the far right, this side, is always going up. Okay? Both of these. Okay? If the degree is odd, then the two ends go in opposite directions. If the degree is even, then the two ends go in the same direction. Okay? So the leading coefficient tells us the far right, this end, towards positive infinity, up or down. Positive leading coefficient, this end's up. Negative leading coefficient, the far right is going down. Okay? Odd degree, they go opposite directions. So these two are going opposite directions. Even degree, they go in the same direction, the two ends. So I can tell just by looking at the problem what's happening at each end. That's what they mean by end behavior. You just draw arrows. You can say positive and negative, however you want to do it. I just draw arrows. Okay? So, is this in the right order, first of all? Okay. So, highest exponent down to the constant, right? Again, there's an x squared missing if we were doing synthetic division or long division, but we don't need to worry about that part. All I worry about is this. Oops, I need my pen to show up. I just need to look at that first term. Okay? And then I look at this sign. If it's negative, that means the far right is going down. That's this side. Look at my degree. Is that an even or an odd number? Even. If the degree is even, they're going the same direction. So the one on this side is also going down. Okay? So since it's got a 4 here, if I were to look at the actual graph, it probably looks like an M. Okay? Because it's got 3 changes of direction. It probably, most of the time, whatever this degree is how many times it'll cross the x-axis. So I go up, crosses the x-axis, I go back down, second cross, go back up, third cross, go back down, fourth. So it's going to look like an M, probably. Okay? Okay? Letter B. I look this, first of all, make sure it's highest degree down to the constant. So I just concentrate on that. What kind of number is that, positive or negative? Positive. So what's happening at this end, up or down? Up. Is that an even or an odd degree, that number? Odd. So that means end's going opposite direction. So it's going to be like this. Okay? So this end. So always do the right end first. That positive infinity end. What's happening? It's going up when that's a positive number. Okay? All right. Leading coefficients, negative 2. In the right order. The degree is 5, which is odd. And behavior, since that's a negative, the far right is going down. Since this is an odd, the far left would be going up. Opposite direction. Odd degree, opposite direction. Okay? If I were to put it in my calculator, this is something you can do if you want. To graph something, you got to hit your y equals button. And remember, negative signs down here at the bottom. So negative 2x to the 5th plus 3x squared minus 4x minus 1. And when you hit graph, watch it. Sometimes you'll see it come down first, and sometimes you'll see it go up first. All right? Okay? So since this end is going up, when you watch it, it should come down as it starts going. Okay? Oops, the graph, sorry. So down. Oh, we only see it go one time. All right? Because it probably doesn't. So I probably have to say zoom. Let's try zoom 0. That's zoom fit. See if we can see the whole thing. Yeah, it's hard to see. There it goes. All right, so as you can see, the far right's going down and the far left is going up. So I hit zoom 0 to try to get it all to fit in there. Okay? I don't know if it crosses through there or not. Maybe not. It's kind of hard to tell from that one. All right? To get it back to normal, you hit zoom 6. That's zoom standard. All right, and all we see is it go down. We don't see it over here, what's happening. Okay. For this one, we've got a leading coefficient of -3. Degree is 2, which is even. All right. So since my leading coefficient's negative, the far right should be going down. And since it's even, the degree, the far left would be going down too. They go the same direction when the degree is even. Okay? And that's just a parabola. Again, if you want to go to this, you can. Just hit clear. -3x² plus x plus 1. Graph. You can see it came up and then it went back down. So both ends are going down, same direction. Is this making sense? Again, we went over this last year. Hopefully it's coming back to you a little bit. All right, so this one, you're looking at the actual graph, and you're going to tell me has odd and even degree or positive or negative leading coefficient. All right, so all you got to do is you don't have to tell me the actual number, just positive or negative, and then if the degree is even or odd. All right, since they're going opposite directions, what's the degree? Odd, right? Starts with an O. Odd degree. O, opposite directions. All right. Looking at the far right tells you, is this positive or negative? If it's going down, negative. Okay. The degree is probably 5. 1, 2, 3, 4, 5. Yeah, because it crossed 5 times, which is an odd number, right? But you didn't have to tell actually what it was. You just had to tell if it was even or odd. How about this one? Even or odd degree? Even, thank you. Since they're going the same direction, that means my degree is even. And that leading coefficient, looking at the far right, is going up, meaning positive or negative. Positive, up, positive, down, negative. Okay? And it's probably a positive 4. 1, 2, 3, 4 that it crossed the x-axis. All right? Odd or even degree? Like this. Opposite directions, odd or even? Odd. Leading coefficient, look at the far right one. Positive or negative? Negative, going down. Okay? See how easy that is to figure out on those types of problems? Okay? All right. Steps for graphing. Again, this would be if we had to do it by hand. All you got to do is punch it in your calculator to graph it. Okay? If you have to graph it, just put it in your calculator. Hit your Y equals button, type it in. All right? All right? So there's this thing called possible rational roots. All right? Try to figure them out. There's this rational root there. We don't have to do that because we can use our calculator. We're just going to go to our Y equals and put that in. So X, remember, is right here, next to alpha, between alpha and step. Caret, third power, plus 4x. There's the square button, or you could use caret too if you want. Plus x minus 6. Okay. So it says identify the possible rational roots. Rational roots are where it crosses the x-axis. It looks to me like a -2, -3, and a +1. To look for sure, you can go, let's do this first. Well, I think it might have a picture of it, actually. But you can look here, but you can go to your table, which is second graph, and you're looking to see where y is 0. So there's a 0 right there, the x value is -3. There's a 0 right there, the x value is -2. There's a 0 right here, the x value is 1. Okay? So your calculator will tell you those if they're whole numbers. Okay? If they're not whole numbers, I'll show you what you can do. All right? It says also find your y-intercept. What's your y-intercept? When x is what? 0. So the y-intercept would be -6. Okay? All right, but again, we're just using our calculator to help us do this stuff. Okay? That's what they did. Here's the 3 zeros, and then right here, 0, -6 is the y-intercept. Okay? So it says graph the function. All right, we're just doing it on our calculator. All right? You know, plot the points as guidelines. And then I think they want you to graph it up. Okay. Identify the end behavior. The degree is odd and the leading coefficient is positive. So since the leading coefficient is positive, this side's going up. It's always the far right that positive number or negative number tells us what's going on down here. And since it was odd, it was to the third power, right? Means the other side is going the opposite direction. Okay? So identify the end behavior, and then you sketch it. All right? But you guys can sketch it by looking at your calculators. Your calculator is going to do the graphing stuff for you. Okay? Any questions on using your calculator again? All right, so calculator is doing that work for you. Okay? This one, again, just go to your y equals. Clear it out. We got x cubed again, minus 2x squared this time, minus 5x plus 6. All right, so it's a positive leading coefficient, so this end's going up. It's an odd degree, so this end's going down. Okay, so again, before we had these graphing calculators, we'd have to figure all this stuff out a little bit. All right, we don't have to spend too much time figuring that stuff out. It looks like a -2, a +1, and a +3 are my zeros. So if I go to my table, -2, a +1, a +3. My y-intercept is 0, 6. Again, you can just sketch it, and then you can look here if you have to answer those questions. If they ask for those things, then, you know, this part we don't really have to test anymore because, write it in factored form. Okay? So going back, x squared minus 2x minus 5x plus 6. Okay, and according to, oops, let's go back here. According to this, I got zeros at -2, at 1, and 3. All you got to do to factor then is write x minus in front of all those numbers. Okay, so minus -2, minus 1, and a minus 3 to write it in factored form. What's minus a negative? Plus. So we would change that to plus. So if I were to multiply these three together, I would get this answer. And then it says, you know. All right, so they're just plotting some points, you know. Plot points between the zeros, choose -1 and 2 for simple calculations, you know, so they did. And what you can kind of tell what's happening then. So that's more by hand stuff, okay? But again, the zeros are where it crosses the x-axis. So that's how you can factor it. Just write x minus, once you figure out the zeros, in front. If it's a negative, then it becomes x plus. Minus a negative is a positive, right? You guys all knew that. Okay, so our calculator is doing a lot of work for us. Turning points, that's when it changes directions. Okay? The turning point is where the graph changes from increasing to decreasing or from decreasing to increasing. A turning point corresponds to a local max or local min. Okay? Maxes are when it's going up and then starts going down again. Mins are when it's going down and starts going back up again. Okay? So if we go back to the one we just had here, this is a max, and this is a min. Your calculator will find those for you. Okay? So let's go to a problem. It says, if the degree is n, let's say 5, it has at most 5 minus 1 or 4 turning points. Right? If the degree is 4, it has at most 3 turning points. At most. It doesn't necessarily have to have that many. Okay? But at least the most it would have, I guess. Or I guess at most, yeah, at most. All right, and at most n x-intercepts. So like I said, if it has a degree of 4, it has at most 4 x-intercepts. You can use graphing to estimate maximum values. Okay, so if I put this in my calculator, go to my y equals, and hit 2x cubed minus 18x plus 1, and graph it. All right. All right. They made it fit. All right. If I hit zoom 0, let's see if it fits. See, I don't like that. Let's go back to zoom 6 for the first one, and then let's go zoom out, number 3. Let's see what happens. You can tell there. You can tell a little bit, but it's still not it's not nice like that one. What they did is went from -5 on the y to +5 and -25 to 25. You can change that if you want. That's the window. All right, so the x min in this picture is -5, and the x max is 5, and just going by ones, and then by ones, and then they're going from -25 to +25, and going by ones, I believe, and then you hit graph. Okay, that's how they got that to look like that. But you're not sure what that's going to be, right? So usually you'll just have it in the normal mode, which again is Zoom 6. All right, that's Zoom standard. All right, so see how it's going second trace here? If I hit second trace right next to graph, that's my calculate menu. If you look at number 3 and 4, it says minimum and maximum. So it'll find it for you. I just have to show you how to do that. It also finds 0 if you can't, if it's not a whole number 0 like these, that looks like -3, a 0, and a +3. Okay, if it's not a whole number, it'll find that for you. Okay, so anyway, all right, I'm going to look for the min. So that's this one here, right? I'm going to look to see what that number is. All right, so I'm going to hit 3. And then it's going to say left bound. And then it's going to ask me right bound. And then it'll say yes. Okay? So when it asks you left bound, it knows theirs might be different mins and maxes through there. So it wants you to tell it where you want it to look for this min and max value. Okay? So when you see that left bound question mark, it's just telling you to kind of help it zero in where you want it to look. Okay, so usually what I do then is I'll move the cursor down here towards it, around there. Because I'm looking for this point. Right here I'm left of it, correct? I'm using L for left. So you want the left of it, and then over here, it'll ask me for right. So I'm going to move that cursor over down here. It's right here right now. When I first start, it always starts at the y-intercept. In this case, it's at 0, 0. Okay? See it blinking? Oh, it's at the y-intercept. It's at 0, 1. Sorry. Not 0, 0. Okay? It tells you where it's at. These two numbers tell you where the cursor is at all times. Okay? So if I hit the right arrow key, watch, the cursor moves. And it tells me right where the cursor is. Now, I can't see this part right now, can I? Okay? But you do know that it comes back up, right? So you know that you're left of it right now. So if you wanted to hit left, if you want to hit enter right now, you could. All right, so I'm just going to do that. I'm going to hit enter. And it's going to ask me for the right bound. All right, it's going to be right bound. So what I got to do is I got to get it around the bottom and start bringing it back up. So when I do this, and I can't actually see it, Maddie, I watch this. I watch these numbers. Okay, so I hit it, it's at -6.5. I hit it again, it's at -9.9. I hit it again, it's at -13. I hit it again, it's at -15. It's still going down, right? I hit it again, -17. I hit it again, -19. -19 again. So I'm getting close to the bottom. Making sense? Because my intervals are going a little bit smaller. Now, what am I looking for to make sure I know I'm around the bottom? What's going to happen to those numbers? Well, they'll start doing what? They'll start going up towards 0, right? Does that make sense, my thinking? You can't really see it, but you know what's happening by just watching that Y value. -19.4, -18. What's happening? -15. I made it around, didn't I? So I could hit enter now and I would be right of it. Okay, so I narrowed down where you wanted the calculator to look for this point. So I'm going to hit enter because I know I'm coming back up. And then for guess, you just hit enter. And it's going to tell me what this point is right here. Hit enter. There we go. So it's 1.7, and we'll just go to tenths, 1.7. And -19 something, right? 19.8. So you're not going to get nice whole numbers all the time. That's okay. Okay. It's going to ask me for that. That's the local max, right? I'm looking for that point now. Now, over here would be left, and over here would be right. Correct? So I'm going to go, how do I get to that calculate menu? Second trace. Second trace. Second trace. All right. Now I'm looking for the max. I'm going to hit 4 for max. Left bound. So right now it's at this spot. So I'm going to have to hit the left arrow key, and you'll watch the Y values get bigger. You'll see the cursor, and then we won't see a little for a while. It'll keep getting bigger. Then all of a sudden it starts getting smaller. When it starts getting smaller, what do I know? That I'm left of it, right? So you can hold that cursor key down, and it'll go a lot faster for you. If I hold it down, it'll go crazy fast for me. So I have to hit it like this. There it is. It's moving up. -2, 1, 4, 8. Still can see it. If you wanted, you could just hold it down until you start seeing it over here, blinking. You could do that too. All right. 15, 17.7, 19.8, 21.2, 21.7, 21.4, 20, 17. What happened? I passed it, right? I'm left of it. So I can hit enter. Now I got to watch again. I got to go back up and start coming down again so I know I'm over here. All right, so hit my right arrow key, 20, 21.4, 21.7, 21.2, 19.8, 17.7. I'm coming down, right? So I'm right of it. Hit enter. And then for the guess, hit enter. And it'll give us that point. -1.7. And 21.8. That's our max. And this was our min. Calculator will do it for you. You just have to, punch in some things. Before you get there, again, you get to do that. You hit second trace. It's right next to graph. Calculate, and you're looking for min and max. Left. Bound. Make sure your cursor's left of what you're looking for. Right bound, make sure your cursor's right of what it's looking for. If you can't see the very bottom or top, like that one, doesn't matter. You can watch it, okay, as it moves. Questions on that? You're going to have a couple problems like that, where you're going to have to find those. Okay? All right, so again, we have to find that's the max, and we have to find that's the min. Okay? Just using our calculator. All right, the other thing that you're doing, remember, was this part. Let me go through that again quick. When it asks you to write in factored form, find the zeros. Remember, that's when the y is 0. You can look at you can find zeros that way too, doing the same thing, or go to your table and look for zeros over here. I don't know if there's any showing out there. No. So this is one we'd have to use our calculator to find. It goes it's between -3 and -4, the 0, because it goes from -55 to a +1. So it crossed the x-axis. It goes from 1 to -15, so it crossed the x-axis again. Okay? And it might, do that again somewhere else. Doesn't look like it there. So when you looking for zeros, you can't find them. You went from a negative to a positive again, so it crossed the x-axis again. So there's another 0. right? You can find it on your calculator. It will find them for you if it's not in the table. Okay? So factor form, again, once you know what the zeros are, you just write X minus, and then put those numbers after it. Put it in parentheses. All right, I don't know if this asks for that. And behavior, you can do that by looking at it. The leading coefficient was positive, so the far right was going up. The degree was odd, so the far left was going down. You can look at it and see that. Okay, turning points we call mins and maxes. Okay, I just showed you how to find those. I think that's it. That was just another example there. So you only have 11 problems. Calculator work. Some of it's just drawing arrows, like we were doing in the beginning. Some of it's telling me if it's a positive or negative leading coefficient, or odd or even degree. Remember, opposite directions, odd degree, same direction on each end, even degree. Remember, positive leading coefficient, far right goes up. Positive or negative leading coefficient, far right goes down. So do that part first. So lots of stuff I threw at you today, but a lot of it's just calculator work. Hopefully, it won't give you any issues.